Check the localized stress data right here.
It's negligible. The alpha case depth is perfect according to the scan.
A sophisticated ultrasonic phased array probe scans the titanium stock, mapping its internal structure. The dedicated hydraulic pumps are tested for high pressure output. Optical comparators check for micro defects before. The dedicated hydraulics for the thrust vectoring nozzle full out.
The dedicated hydraulic pumps for the thrust vectoring nozzles are assembled and tested for high pressure output.
This controlled cycle of heating and cooling is essential for enhancing the titanium's strength.
Eclipse. The small, gray titanium parts are submerged in agitated chemical baths, meticulously removing contaminants.
An automated vacuum tool seats the proprietary dark green elastomeric seal perfectly into the machined groove.
As the titanium end cap is integrated, automated torque drivers secure the high tensile fasteners to precise digital specs.
Here, the newly assembled hydraulic unit under initial functionality testing.
During the low-speed run-in, a high-resolution infrared camera captures the thermal profile of the gray titanium pump housing, confirming minimal internal friction. Initiating cyclic loading profile.
Confirming structural integrity. Wait, acoustic spike on channel 4 during the transient.
We've passed the fatigue test cycle. No degradation detected.
Excellent. The data confirms long-term reliability.
The exterior of the pump is meticulously cleaned and prepared, and critical interfaces are masked before a special
The thrust vectoring hydraulic pump successfully passes high-pressure testing, confirming Process A is complete and the unit is awaiting integration.
A thin layer of proprietary ceramic composite material is applied to the pump housing, enhancing thermal insulation and abrasion resistance.
And trained. The dedicated hydraulic pumps are assembled and tested for high-pressure output. A high-resolution. First, specialized metal caps are installed and tightened to a low torque. Then, a final visual.
The thrust vectoring hydraulic pump undergoes high-pressure testing before integration. All production data is
The hydraulic pump undergoes a nitrogen purge, visible as a slight mist, before automated welding guarantees hermetic integrity for transport. The AGV delivers the packaged pump unit to the ASS input bay. A large robotic arm
With the hydraulic pump assembly complete, testing confirms high-pressure output. The team now shifts focus to the structural mount.
The dedicated hydraulic pumps for the thrust vectoring nozzles are assembled and tested. A massive 5-ax CNC machine.
A robotic measuring probe immediately follows the cutter, verifying the depth and positional tolerance down to 5 micrometers.
Detailing the system powering maneuverability. The dedicated hydraulic pumps for the thrust vectoring nozzles are assembled, tested, and
The CNC machine drills and reams the deep, high-tolerance hydraulic fluid pathways. A long drill bit penetrates the
Detailing the system powering maneuverability, the hydraulic pumps are tested before integration. Robotic sprayers then apply a crucial layer of radar-absorbent material. Detailing the system powering maneuverability, the dedicated hydraulic pumps are tested for high-pressure output and integrated into the complex aft fuselage structure.
Detailing the system powering maneuverability, the dedicated hydraulic pumps for the thrust vectoring nozzles are assembled and tested for high-pressure output.
The dedicated hydraulic pumps for the thrust vectoring nozzles are now being integrated into the aft fuselage structure.
Easy, bring it down 5 inches.
Hoist clear of the dolly, moving to alignment point.
Copy that. Coming left 5 centimeters. Steady. Very steady.
The thrust vectoring hydraulic pump is carefully guided into its dedicated pocket. The technician aligns the drive shaft.
Technicians connect the high-pressure fluid lines to the actuators. ensuring robust connections.
The culmination of Process A and B. The thrust vectoring system is complete as the F-22 is towed out for final testing.
Ground clear on the left side. Acknowledged. Final systems check complete. You are clear for takeoff.
After high-pressure testing, the pumps enable immediate downward vectoring upon rotation, providing critical extra lift during takeoff.
The aircraft pitches up dramatically. The thrust vectoring nozzles snap instantly into a severe downward angle. The dedicated hydraulic pumps are tested for high pressure output, allowing the nozzles to vector laterally. The Process B structural
telemetry confirms full thrust vector engagement.
Visual correlation is good. The nozzles are responding exactly as modeled.
detailing the system powering maneuverability. The dedicated hydraulic pumps are tested for high pressure output and integrated into the complex aft fuselage structure.
The F-22's thrust vectoring system allows for unparalleled precision.
Ground, this is 42. Clear the active, shutting down engines. Thermal scan complete on the vectoring nozzles. Process B mount is running cool.
The dye penetrant test is crucial for detecting microfractures in the titanium structure after a high-G flight.
The Process B mount shows safe handling across the envelope.
Confirmed. We are green across the board.
The A-short spooper enable an instant sprint. The short sector vectoring system is directly attributable and a titanium stroke on.
The dedicated hydraulic pumps for the thrust vectoring nozzles are assembled and tested for high pressure output, demonstrating the